Welcome to our last section on pandas. In this section, we will use everything that we have learned so far, and based upon that knowledge, we will perform an analysis on the Google Play App Store. So, without wasting any time, let's jump into our Jupyter Notebook. So, here this is the problem statement that we are going to perform. So, we have a Google Play Store dataset that has been downloaded from the Kaggle. I have provided this file with this video. Our aim is to explore the dataset and make it presentable. So we are not going to create any model over here because you cannot create a model using a pandas only. You require more libraries for that we are going to learn in the further modules. We will prepare a dataset ready for the model creation. Using pandas, we will handle the missing data values, create and delete columns, divide the dataset based upon the data types. Using matplotlib, we will present the data in a pictorial form that will be self-explanatory and attractive. So while working with the matplotlib, if you were confused about anything, just don't worry about it, because in the matplotlib section we have covered everything related to the matplotlib. So let's get started. So these are the steps that we are going to follow. Step number one is importing the relevant libraries. Then we are going to inspect the data, where we will be seeing the data, we will be reading the data, and we will try to understand the data, like how we can solve a particular problem with the data. After that, we will clean the data. See, before we can go ahead and use the data set, it has a lot of values, missing values, incorrect values, and there are a lot of things that we can create from the available values. That thing will be done in the data cleaning. After that, we will talk about data transformation, where we will be converting the data types of the columns. So let's suppose if there is a column that can be converted into an integer values, then we will do that, because integer values are very important in the data set. As using them, you can perform a lot of things like calculations and all. In the end, we will perform exploratory data analysis, where we will show you the ratings of apps based upon the category, and we will be using a matplotlib in order to display a chart or pie chart or any graph or line chart. So whatever the requirement is, based upon that, we will be displaying that. Total apps in each category, usage based upon age, free and paid installations. So let's get started with this thing. So first thing, we are importing libraries. First is pandas and another one is the matplotlib. We have already installed the matplotlib. If you have not installed it, you need to install it. We have explained this in a previous video. Once the data set has been imported, it's time to inspect the data. So for inspecting data, our first step is to read the data set. So this is the CSV file that we are reading, and we are storing the value in the df variable. Let's run it. Let's see the top 5 rows of this data set. So we have app, category, ratings, reviews, and these are the values. Rating have the numerical values, reviews have the numerical values. Size has a string values. Then install is also having a numerical values, but it is in a string format because we have a plus and a comma over here. This value can be converted into a numerical values. Then we have a string, which is a type free. So there are only two types. One is free and another one is paid. So we will check for that as well. Then we have price, which is already seems to be in a integer form or a float form. We have content rating, genres, last update, and current version. We have last update a date over here, so date can also be used. So let's see the last 5 rows. So last 5 rows shows that we have 10840 rows. Then we have same apps, category, rating. Now let's see the shape of this data set. So shape is the total number of rows and columns. Also we will see the multiplication of both of them. So this is total number of columns. So this is total number of rows available here, and 13 is total number of columns. And if we will multiply both of them, this is the result. So if we will multiply both of them, then this is the result that we will get, which is the df.size of this data set. Now let's see the names of this, all the columns. So we have app over here and then category. So we can just find out how many apps are there in each category. Then we can also categorize based upon the ratings. So which category is having a maximum rating and minimum rating. All this thing can be found using the columns over here. Now let's see the data type of each column. So app has a string data type, then category is also having a string data type. Rating has a float, which is good thing. Then we have reviews. Reviews has a string data type. So earlier we checked that reviews have numerical values, but the data type of it is string. So we have to change this. Size is object, so we don't require actually a size. So it can also be used in further things. Also we have one more varies with device over here. This is a text available in the size. So if you're working with a size, you can just remove this M from here. Removing M will not fix things because it's a size in MB. So you need to multiply this thing with 1024. And if it is also mentioned KB over here, then you have to do that thing. So there will be KB as well. There will be app size will also be app size will also have KB values in KB as well. So you can do the needful things like 1024 KB equals makes 1 MB. So based upon that, you can just convert this thing. Now we have install as object installs. So let's check installs. So this column is also can be converted into a string, and we are going to do that. Then we have a price. Price is also object. We will convert it into a float values. Content rating. Rating. Okay, let's see rating. Everyone. Okay, so we will leave it as an object. Generic can be object. Last update can be object, and these two columns current version and Android version. So current version and so last update. So last update can be converted into a date time format, and then current version and Android version. So these are in a string format right now, but we can convert it into integers. But for that we will need to remove the string values from this column. Next is we are going to describe the data. So describe will display basic informations like basic mathematical calculations for the data set, but it only performs it on the numerical column. So since we only have a numerical column or the object or the column with the float value, that is why it is showing only for the ratings. So we have total count as 9367. Mean value is this. Standard deviation is this. Minimum is this. 25% of the data is this. So 25% of the data has rating as 4 and 50% of the data has 4.3 rating. So this way, in case if you want to display all the information like for all the columns, then you need to add a parameter which is include. So if I just add it over here, then it will display the information for all of them. So let's see what is the error message over here built in. Okay, so we need to write it inside the quotes, so then it will work. Now you can see that it is, although it is displaying for all the columns, but it is converting or it is showing, let's say the for the app, the count is showing 10841, which is possible. Like you can just calculate the number of rows entry in the column. Then you can also check the unique values. So it must be having some kind of integer values. That's why it is calculating over here. So you can also calculate the number of unique values. Then in most of the cases, you can see that we have nan means missing values. So this is displaying because it is not able to calculate. There is no numerical value. That's why it is not able to calculate. So that's why we, in most of the cases, we just leave this parameter as it is. We don't apply this parameter and we just perform it on the numerical columns. Later in the program, we will convert the few more columns into an integer or float. Then those columns will also start displaying over here. Now let's see the unique values available in the app. So these are the unique values available in the app. We have photo editor and candy camera. We have coloring book. Then we have U-Launch. So these are the things. Then let's see for the categories. So we have a lot of categories over here. We have art and design, auto and vehicle, news and magazines, map and navigation. So all these apps must be lying inside inside these categories only. Now let's check the unique values for the rating. So we are starting from 4 point. So we have 4.1, 3.9, 4.7. We have 19.0. Okay, so this is not a correct value. So ratings cannot exceed 5. Also, we have a missing value which is nan over here. Now let's check the unique values for the types. So we have a free, paid, but we have one missing value and zero. So we need to remove both the things over here. Type can only be free or paid. Content rating. We have group of people based upon their age. We have everyone, teen above 10, then mature 17 plus, adult 18 plus. So this data is can also be filtered. Like there is an improvement required for this data set as well. There is an improvement required for this column as well. Now in the end we have genders. So these are the genders available over here. Now once we have understood the data, we have seen the data, we have understood what all things that we can perform, let's go ahead and perform some operations. So first operation is data cleaning. So we will be removing all the missing values from the data set. So before we go ahead and remove the data, we need to see how much missing data do we have right now. So using isNa function, we can see the missing values, and we are applying sum so that we can see missing values on each column, and we are storing this value in a total missing values variable. So let's run it. We have missing values in the rating column, then we have a type, content rating, then current version and Android version. So one thing we can see that the maximum number of missing values are in rating, and so since we have 1474, so we cannot remove all of them because that will affect the total data set. But we can remove these rows. This is having only 1183. So what we are going to do, first of all, we will substitute the values for this rating column, and we will remove the missing values for all of these. So what we are going to do, let's check the percentage as well. That's also a good habit to check the percentage of your missing values. So for percentage, what we are going to do, total missing values. So here we have found this thing, but if I'll add another sum over here, then I'll get the total number of missing values. So total number of missing values is 1487. So that is the value we are getting over here, 1487. And then the df dot size. Df dot size is the multiplication of rows and columns. So we are going to divide this thing from this, and then we are going to multiply it with by 100 in order to get the percentage. So the total number of missing data, total percentage of missing data is 1.055 and change. Next, we have plotted this information based upon the pie chart. So here you can see that we have 1.1% of missing data, rest 98.9 is the total data. Now here we are going to fill the missing values for the rating column. So we are using method as bfill over here. So what it will do, it will replace the missing value with the value in the next row. So let's run it, and we are also performing it the sum over here. So that means the same operation that we performed over here in order to see the missing values in all the columns. So now you can see rating don't have missing values. We have already filled it, so that's a good sign. Now let's remove the missing values for the rest of the columns. So we have applied df dot drop now, and in place equals to true. We have set it to true so that things could take place then and there. We don't need to reassign it into a same variable name. Now let's run it and check if all the missing data has been removed or not. Now you can see that our data set don't have any missing values remaining now. All of them are 0. Next is, let's see the column once again. So these are the columns, and in this see, while cleaning our data set, so now what we are going to do, there are few columns that we don't require for our analysis. You may require it, so you can just keep it, but in our case we don't require it, so we are going to remove that. So for our case, we are removing current version and Android version from the dataset. So here you can see df.drop columns is equal to Android version and current version, and we have set it to in place. So 2 columns has been deleted. Now after cleaning the dataset, we are going to transform the values. So you remember that we have a few dataset that, so earlier we mentioned that there are some columns that can be converted into float or integers, that means numerical values. So we are going to do that transformation over here. So here you can see that we have mentioned installs can be converted into string, reviews can be price, and we have removed these ones, and we will change the last update into date time column. So let's go ahead and do that. Now here what I am doing, df.reviews.as type. Since this column do not have any other values except the integer values, it was just, we can easily change the data type of it. So let me show you what will happen now. df.reviews.dtype. Right now it is that means that is why it is showing O. Once we will run this cell, it will be converted into int. Next is, we are converting the installs into integer, but the condition is there are some values. So let me go ahead and show you what all are the things that are not allowing it to be converted into an integer. So df.installs.unique. Now here you can see that we have plus sign over here, we have comma, and do we also have some text over here? No, we don't have any text. So what we are doing, using a regex, we are going to remove all the special characters and words from this column. So we are using df install.string.replace function, and inside the replace function we are using regex. So regex has this property which says /w, that will capital W or uppercase W, that will remove all the special characters and words from the data frame. So here we have to set the regex as equal to true, and here we are providing the data type that we wanted to convert it after this thing has been happened. So we want it to be converted into an integer. So we'll do it. Now next is, we are also converting a price. So let's see what is the problem in the price column. So df.price. Now the problem with the price is, we have to remove this dollar sign. So we cannot apply this formula over here, because it will also remove that dot from here. So the prices will be increased. So we just need to remove dollar sign. Now in order to remove the dollar sign, we are using the same thing, which is string.replace, and inside the replace we have provided the character that we want to replace, and we want to replace that character with nothing, like it's an empty string that has been passed. Same thing has been done over here as well. Now regex is equal to true, and this time we want to convert the data type as float. So let me remove these cells. Now let's run it. Also let's check the data type of all of these. So df.dtype. Now here you can see that we have values for integer, like we have integer for reviews, float for rating was already there, and we have integer for installs, and we have float for price. Successful. Now let's jump into how to convert the date and time thing. So in order to convert this last update column into date and time, we just need to use this function which says to_date and time, and we have to provide the name of the column. So df dot, this is the name of the column, and we have to apply this on the PD, that is the pandas. Now let's do it and then just see all the data types. Now here you can see that last update, it has a date time data type. After converting the columns into a right data type, now let's categorize the columns based upon their types. So what we have to do, we have created 3 variables over here. One is for the object, another one is for the numbers, and third one is for the date. And using the for loop, we are applying the for loop on the df.columns. So if I just run the df.columns, then it will display all names of all the columns. So what we are doing over here is, if there is an object, so every time the loop runs, it checks if the data type of that column is object, float, or integer, or data type. So based upon that, it is just incrementing the values over here. So this is what I am getting as a result, 641. That means we have 6 columns with the object data type, 4 columns with the integer or float data type, and 1 column with the date and time. Now using this information, we have calculated their percentage, and we have displayed, here is the percentage, and we have displayed it using a pie chart over here. So we have 36.4% of total columns we have float or integer. Date and time is 9.1%, and rest are object. So let's perform the exploratory data analysis based upon everything that we have done so far. So first we are just calculating the bars. So we have used the group by over here, and we have applied it on the category. So based upon the category, the ratings has been displayed. So you can see the names of all the category over here, and these are the ratings. So what we can get over here is none of the categories having a very low rating. Everyone is having a more than 4 rating over here. Then we are just now here we are displaying the category based upon the app. So in each category we have, like in art and design we have 64 apps, in auto and vehicle we have 85 apps, in beauty category we have 53 apps. So I think communication has the maximum number. No, family has maximum, which is 1968. After that, let's check the unique values for the rating, content rating. So we have these age category. Now let's perform some analysis on this one. So here you can see that. So based upon this analysis, we can see that everyone 10 plus is involved in installing the application, are the maximum number of application installers, and they are the maximum number of people who are giving the reviews as well. So you can see that it is very less, it is very less, this one is also less, and this is the longest one over here. Now free and paid installations. So we are just grouped by using a type and installs. So let's see. So these are 99.5% users are free users, and 0.5% are paid users. Next observation that we can make over here is minimum, maximum, mean rating values. So what we are actually doing here is based upon minimum, maximum, minimum rating, maximum rating, and average of the rating, we are categorizing it into 3 parts. One is poor, moderate, and good. So anyone having a rating between 0 to 2 will fall into a poor category. Then anyone having a rating between 2 to 4 will fall into a moderate, and above 4 and below 5 are called good. So 5 is the maximum actually. So let's run this. So we have a minimum rating of 1.0 and the maximum rating of 5.0, and the average is 4.1. So here we have created labels and bins. So labels and bins can be used in the cut function, which allows us to display based upon the category. So we are also creating new column with the name performance, and pd.cut. Inside pd.cut we are performing it on this column, which is rating, and these are the bin equals to bins means the list of categories that we want to apply, and this one categories, the label that we want to display against that category. Now let's run it. So we have to run both. Now let's see our first 5 columns of our dataset. So we have app category, so it must be at the last. Now here you can see that we have performance. So performance, it is showing good because it must be having a rating of 4.1, above 4. It is showing moderate because the rating lies between 2 to 4, so 3.9, that's why. Now let's plot this using a bar chart. So here you can see that this is for poor, this is for moderate, and this is for good. So this is how you can perform the analysis on this data set. This is just we have prepared the data set and it is ready to be created for a model. In further sections, we will be discussing about more libraries that can be used with this data set, and you can just perform a good data analysis. You can create a model that will help the world in solving some kind of problem. So with this, we have completed our module on pandas.